Hey everyone, welcome to another stream. I'm gonna be finishing up the what we started yesterday, and then we could start working from there. So today, so yesterday we tried to build uh, a server-side event server, which just means that we're able, a server-side event server in Go. So what we're trying to do is send events from the server to the browser. So yesterday we were able to start sending events. So we were able to start sending events. Yeah, we were able to start sending events. Give me a second. We were able to start sending events to our local server. So we could do something like this, and then in here we were able to connect to our server. So I just need to find where yeah, the JavaScript. So we were doing something like this in a just do this one, and then if I refresh this one, then we could see the events. Cool. So the page is just gonna keep spinning because, again, since we're doing a server-side event, so the way the server-side events work, just a recap from yesterday, is that it just keeps the connection open to the browser and the server never closes it. So it's just going to continue making a request to that endpoint. And as you can see in Chrome, it just keeps spinning. It never finishes spinning. So it's just going to keep going. And we could connect to the source like this. And that means we could also listen to the events here. So we could do something like event. So the goal, what we're trying to achieve, and the reason why we're doing this, is to be able to show when a new subscriber subscribes. I want to be able to put it part of the stream. So I'm kind of building the necessary tools to be able to do that. So I'm gonna use the Twitch API to be able to connect to. So I want to be able to connect to the Twitch API, and every time there's a new subscriber, I want to send an event saying, "Hey, there is a new subscriber," and then also add the new subscriber name into the stream, so we could see it real time when people are subscribing to the channel. So that's kind of what we're trying to achieve today. So today, their goal for today is to finish our server-side event. Sorry, our server event. Sorry, it's called server send event. I keep getting it confused with server side event, which is something else. But yeah, the goal is to be able to finish the server send event, and we could use that to then start using the Twitch API. Yeah, so that's still working. I need 1 second to fix one thing here. So I need to fix my screen here, which stopped working. But so the thing that is happening is that my display is not being captured correctly. So I just need to fix that. And there we go. Yep. Cool. Let's make this bigger. Yeah, so for some reason, OBS was not capturing my monitor. So I wanted to fix that because I'm going to use this monitor a lot more. I'm going to use a full monitor a lot more. Cool. So let's see what we had from yesterday. So yesterday we created a structure called stream, which is the one that is handling all the events. And then inside of that struct, we have a message, a channel that is takes a stream, and then that that it then gets sent to all the clients that are listening to. So any client that is listening for those events. So the way that we did it is that every time someone hits this URL here, an event is triggered here, and then we could see it that is coming in here as an event. So event is a type of event, so we could name it whatever we want. So right now it's called pin. And then the data is whatever we're sending from the API. So what we're sending from it is that we're sending hello world here. So we're sending a pin, we're pinging, and then we're also sending hello world as a part of data. So let's make sure. Oh, I see. So it's not sending hello world. It's sending. So hello world is hard coded, but yeah, it's sending that. And then if we look at the logs that we're printing out, we could see that it's sending hello world. So the message is correct. So today's goal will be to clean this up a bit more. We have one giant file with all of this in here, so we could set it up we could separate it into multiple files. And the thing I want to do is write tests for this as well. So we could do a bit of testing, and we could do a bit of more of like, and then we could split it up. When we're done with that, we might start using the Twitch API to be able to start getting the latest follower. So that will be the goal for today. Cool. So one thing that I wanted to make sure that I could get to work I also missed was shutting down the server. So currently we don't have a way to shut it down. So if we go here and we try to shut it down, it's just gonna time out. So I want to be able to shut it down. And to do that, we could look into, we could go here and we could see how our main server is shutting down. So our main server is using a signal. Okay, so to shut down, the way it works is that it's just getting a signal to shut. So a signal is being passed through a channel. A signal for shutdown is being passed from OS signal, and we're listening to the OS interrupt, and then we're passing that down all the way to stop. So we could reproduce that for ourselves. We could just use most of this to make sure that we get what we want. So let's just look at server. And then, yeah, so I will have to change. So, we'll have to change is, we have to change shutdown to type, to be a signal type. So we could start using the signal, and then shutdown. Let's see. So shutdown. I will have to fix this shutdown here because it will look different since we're not going to do it manually anymore. We're going to have to use interrupt. So shutdown, and then I will have to rename this to, I will have to declare a new variable here called shutdown, and then do make. So we want to just pass it down to the notify function from the OS package. And I believe we're passing it 1 to here. Yeah, we're just doing size 1. And then we just have to replace this one with shutdown. So what we're doing now is so we're still working on the shutdown side of things, but I want to make sure that when we press, like when we tell the server to shut down, it starts closing all the connections and starts closing all the channels, and then start moving on from there. Because if it doesn't shut down, it just timing out, and that's why it's taking so long to shut down. But it would be nice if all the connections are open to the server send event endpoint. We just shut it down, and then when we shut it down, we could just like take it from there. So we could do, so I believe, let's make sure. Okay. Signal, notify, and here I think we only have to pass the channel to it. Yeah, we pass the channel, so shut down, and then we have to pass the signal that we want. So we want, let's see, we want interact. So pretty much anytime that the server is going to get interrupted, we want to be able to pass it down. And then, right, so now that we have that, we're able to listen for that signal. So the way that I will change things here is let me put that from there, but then do, okay, so we should be getting the shutdown signal now, so we could try that. So let's start it up. Cool, so it's running, and we know that there's a client connected, and then if I kill it, it should just kill it, but it didn't print the message that I wanted it to print. So I wonder, maybe there's no client connected. Let's just try this again. Okay, so that's connected, and then this is connected. I think it's frozen. So let's just run. Oh, it's already go. So just refresh and then see what happens. So it's getting it back. So that's working, sending client event. But if I just turn it off, so it's shutting down. So the thing that I have to do, one thing I thought about after the stream ended is that I didn't close all the channels, right? It's like I close, so I don't, there's extra channels that we don't need. So one thing that we could just do is like just use the same for loop that we have when sending when sending the message. We could use the same for loop to just go through all the clients that are connected and just close all the channels. So this is what we're gonna do. We're just gonna close all the channels. So the only thing we have to do is close our own channel. So we're gonna close that channel, and then so it's closing the client channel, it's closing the message channel and the deleted channel. So we don't need we don't need these two channels. Oh wait, we do need that channel. So we need disconnected. We don't need this one. Yeah, we don't need that channel. And the only ones we have to close is the ones that manage the clients connecting and the clients disconnecting. So we could close those. Client connecting. And then the disconnecting channels. So that means we're only depending on these 3 channels for our own server. Cool. So shut down there, and now I will need to change the handler too, because the handler for the server itself is just listening to that event too. So we don't need another way to do this is that when you get a response from a channel, you get also okay, and then you could do something like you could check if it's okay. If it's not okay, that means that the channel was closed, and then we could just close it. So we could do something like this, and then we could get rid of, we just call this message. And then here we could do if okay. So if it's not okay, we want to just break out. So we're breaking out, and then we just need to keep this here. We need let's see if these changes work. Let's try it. So go back here, refresh. That means you got an event, so that worked. Then let's just do write this one here with the JavaScript, which is what we're going to be using. Then we refresh again, and then we get the event. So that's working. Now if we exit out of it, we should see still takes 5 seconds. So 5 seconds. So let's just make sure that it's shutting down correctly when the channels are closing. So we make sure that it just like exit out. Let's see. So we just you can just print out, see the different messages. Let's see if we're closing all the clients. So let's do that. So let's see if the client itself is closing, and then if it's closing, so if it's closing, it should just hit here. So we can just do print here, and then that means that if it comes here, the client just exists and it's just gonna exit out. Cool. So let's try that. Okay, so client connected, which is the browser. So let's just refresh this one. So that is going. We have a new client connected. Then we refresh. That means we got a message, and yeah, we got a message, and then we did close it out. It looks like they went. Okay, so there's something going on. So we never get here to line 94, so we just have to find what is wrong with 94. So this message here gets printed. Then let's see if these channels get closed. So here, so we just want to make sure that the clients, we need to make sure that the channels for those clients get closed, so then we could make go through it. One of the issues that might be happening is that since we are so if you're waiting, the channel will be, so right now the way that the code itself is doing in this line here is that it's gonna block until something happens. In line 83, it's just gonna block until something happens. So unless something happens, it's just gonna block there and wait. But in the case when you close the channel, okay, should be the channel should send a closed message, should receive a closed message, then this should be false, and then it should work out. So let's see if that is the case. So cool. So we send a message to it, and we get a message. Then we kill the client at the server, and then it's closing. So okay, that's closing. So that means that we're closing the event as we go. So we're looping through the clients and closing the channels. That's being closed. And then here So let's just leave that one there and just get a new one. This is shutting down. Shutting down. Go through that, and then we go back and we refresh the page, and now we should have a client connection, and then see if we get a response back. So there's a client connected. We refresh, we get an event, and then we close it, and it's shutting down. And then so the issue here is like we're going through all the clients, we're closing all the channels, but for some reason when the channels are being closed, this is not being fired. So I want to make sure, I want to see what is happening here. So let's see what's happening here. So OK might not have the information that we want. Hey, how's it going? To recap what I'm trying to do right now and the goal of today. So for a recap of what we're trying to achieve today is I'm trying to clean up a bit the code. So the code that we wrote yesterday for the server send event that we wrote yesterday, I'm trying to clean up the code a bit more, and I want to make sure that everything works correctly. So I want to go through it. I want to clean up the code. So one thing that I noticed was that the shutdown was not working correctly. So when the server is told to shut down, it's just, if a client is connected to it, it just hangs for 5 minutes. So what I'm trying to do now is to clean that up a bit and make sure that it shuts down correctly. So we don't want to wait this long. We just want to, any client that's connected, we just want to disconnect them. So that's what we're trying to achieve right now. And the overall goal of this stream and the following streams will be able to, I want to show when someone starts following me for the first time, I want to show their name as part of the stream in real time. So that's kind of how this project is going to be connected. So the first part is the server send events that we're working on right now, and the next part will be connecting to the Twitch API. So that's kind of how we're going to split our time today and in the next couple of days. But yeah, so for now, I'm just trying to figure out like the different things, like something's wrong with the channel itself. That is not, we're not getting an event from it. So I just have to make sure that we're getting that event. So we're connected, and then if I refresh, an event is being sent, which is true, and then when I close, so false should come up here. So I don't think our channels are being closed correctly. So let's just go through it. So cool. So we're sending so if you notice in the logs here, we never got a false. So that means that we're blocking here. So maybe I still need the select. Let's just go back to the select for now. Yeah, I think I do need a select because I was expecting that to work. So let's try to select and see if that helps. If that doesn't help, we could just keep digging through it. Let's see. So here, we don't have a client connected. So we have a client connected, and then we send them an event. So we have an event, and then we close it. Yeah, so it's still not being sent. I wonder if it's, so let's check if, let's just remove some of this stuff for now. So we have a clean state. So we know that this is, we're getting a message here. The thing that we're not getting is a close. Do I have, I think I have to send something to it. That might be the case. That would be weird if I, let's just try that. So the channel is closed, and then I'm just gonna send some garbage into the channel. If this is true, if this works, I probably wouldn't use this. So I'm sending an NC string to it. So we close the channel, we're sending something to it and see if it gets fire. But I will hope not, because if it does, I wouldn't want to use it like that. Okay, so we got an event, then we close the connection, it's shutting down. Nope, that is, yeah, this is not. So let's just make sure that the clients themselves are just being closed. Oh, I see. Yeah. This is funny. So you could also range through a channel. So you could loop through a channel. So what I'm doing here is that I'm not looping through the clients. I'm looping through the connection channel, and that is why it doesn't work. Well, like this whole time, I'm just looping through like a empty channel that does nothing. So this should work now. Okay, so we have a client connected, we send an event, then we tell it to shut down, and then it's false, so, and then it just shuts down right away. So that was the issue. So the issue was like I had client connect, which is just a channel, but you could range through a channel. So if you were expecting if you want to just continually loop through a channel, you could do that. But I don't want to do that. I just want to loop through a map of clients and then close all the channels. So I think we could just get rid of some of these messages. So now it works. So if you notice, we went through from waiting like 5 seconds to 10 seconds to just like happening in almost real time, right? So the client connects, then we refresh, we send a message to it, and then now we had a message, and then we tell it to shut down, and just automatically shuts down because we're closing all the connections. And also the event that, so we are also hitting here. So that's kind of the main part that I want to look at. The other thing that I noticed that we were not doing is the disconnect one. So we have the shutdown working now. The next one is disconnect. So when a client disconnects, we're not handling it correctly. So I want to see if there's any way to handle that. So like if a client disconnects, I just want to remove it from the map. And I want to make sure, yeah, I just want to make sure when the client disconnects, I take it, and then from there I can just handle like the disconnection from it. So I just have to figure out how disconnect works. Give me a second. So the thing that we're looking for is a way in Go to handle HTTP when a client in HTTP disconnects. So let's see if there's anything. So we just want to make sure that there's like a notifier or something like that is going to notify us when a connection is closed. So the way that will work is that when a client disconnects, oh, there's a close. So when a client disconnects, we want to be able to be like, okay, so this client is disconnecting. So since it's disconnecting, we want to make sure that, so when it disconnects, we want to trigger an event saying, hey, this client disconnected, so you should remove it from the map that we're using to keep track of all the clients. Since that client is not used anymore, we should just, sorry, since that channel is not used anymore, we should just remove it from memory so we could save some memory. So I don't think they have any examples using this, so we might have to look at the code base itself. Yeah, so we're just gonna look at the Go code base and see if there's any examples of anything using this method here. So, oh, and there is. So always, if you want to figure out how something works and you cannot find it anywhere, just look at how other how it is used in the Go code base. So the one we want to be able to, we don't want to call notify itself. We want to be able to like, so notify is not what we want. I think it's closing the client. So, oh, it is. So, but how do I pass my own channel to it? Like I want to be able to. Let's see. Okay, so I think it returns a channel. So the way it works is it returns this channel, and then we could use that channel to know if the connection was closed. So let's say that I close that connection. We can know if it's closed or not. So let's give that a try. So I will have to change this back to using select because I want to listen to multiple channels. And the way it will work is that the for loop itself will only run when this message, when this channel gets a message. So right now it's blocking here. So it just stops running until it gets a message. And then when it gets a message, it goes through the rest of the logic. So it goes from here and down. And then since it's a for loop, it's going to go back into line 81. And then it's just going to block again. So what we need to do now is a way for us to handle multiple channels. So we just have to use select here. And then this will be the case. This will be case 1. Oops, I messed up the syntax. So case 1 will be this here. So, and then case, and then we will have to create a new one. But for now, I need to fix. What do I need to? Let's just use the notifier first. So for the notifier, I just have to do. Okay, so the writer again. So for the writer, I could just do. I could just cast the writer to this new interface. So it's http dot notify. Let's see. HTTP. Oh, it's close. First notifier dot close. So now we have that method there. So that channel has the information that we need. And then here we could just do. We don't need the value of it. We just want to get notified when it closes. So now we know that it's closed. And then we just have to send now an event back into our streaming event saying, hey, this client closed, so you should just delete it. Disconnect it, so you should just delete it. So we want to make sure that this works too. So I'm just going to do on the print statement here just to make sure it works. So cool. So if the client disconnects, we want to get notified about it. The way that the notifier, so the HTTP standard package gives us a notifier, and then that notifier could be used to, so it returns a channel. So we use that channel to know when the connection gets closed. And that means that we don't keep just looping forever. So we just return here. And we could return here too. So we were just returning. Sorry. We don't return there, we return here. So we cannot break out of it. We just have to return from here. So let's see how that goes. Cool. So okay, so now the server is running. We connect to the event stream, which says that it's a new client. Then we refresh this, and now we have a new event coming through. Cool. And now, since we have an event coming through, I just disconnect the client. And then the client disconnected. And that means that if I do this, there shouldn't be any clients to close. Yeah, so that worked. But what I noticed is that it's doing, I'm not sure if this is right, but it's sending 2 events. So I might be doing something that is causing it to send 2 events. So I want to make sure that it's nothing crazy. So let's open another tab. Let's just use this for now. Okay, so now we have to start the server again, and then we refresh. Oops, that's the wrong one. I don't want to keep going, so let's just go, and then we go here. I have okay. Let's just stop this and just open a new tab, so we could have a fresh effect. Then, oh, I see. So no, that wouldn't work. So I need to be here. There's no client, so it's not gonna send any kind of event. You say a new client connected, and then we should go here. Then we refresh, and for some reason we're getting 2 events. Why are we getting 2 events? So we're getting 2 events here for some reason. So it's been sent twice. So I just want to make sure that it's nothing too crazy that we're doing. Okay, so is it adding a client twice? Let's see. There's no client. Oh, would it be buffer it? Nope, there's one client connected, and then we send an event to that one client, and it gets 2 messages. Why did it get 2? Okay, let's see. Let's just look at our messages. Again, so it's printing. Just get rid of some of the print statements. And here we could use so this will let us use the message as a string. Oh, yeah, we don't need to do that. Let's just do that. So we just want to use it. We just want to pass like multiple values. We just want to use like a replacement. So we could do data s plus that, and then pass message. So this will allow us to, it's going to let us just print whatever we're posting to it as part of it. I think the JavaScript side of things like reconnects right away. I don't think. So it disconnected and we disconnect again. So then twice again. Wonder if the client's being added twice, but that will be weird if it is. Let's just make sure that it's not. So let's just so again, just what I'm trying to do right now, I want to be able to show my new followers. So if there is a new follower, like I had a new follower 14 minutes ago, and we didn't see that because I was a bit distracted. So I want to be able to see those new followers in the screen while the stream is happening, so I could welcome them. So what I'm building right now is a way for us to do that. So the goal here will be able to create a server send event server where then we could use a Twitch API to pull all our followers, and every time it's a new follower, we push an event into the stream event queue, and then at the end it just ends up popping up in our in the stream itself. So in Twitch it will show up in this as part of the live stream, but it will also show up in my computer, so I could see when it happens. So so it will be like a mixture of both. So that would be the cool part about this, is that we could start building, like, I know we could start looking into how to do push notifications into the Mac OS. So that means I could show it and I could hear it as it happens too in real time. So let's just see. Like, the issue that I'm having right now is that when an event comes through, I get 2 of them at the same time. So I need to figure out why it's happening. One of the assumptions that I have right now is that when the request is done, so I think the client is being added twice. So you can see here that it has a 2 next to it. That means that there is getting twice the message when it's supposed to only get once. So I just need to figure out why it's doing that. Then when I figure that out, I'm gonna move on to just restructuring this a bit more and like writing some tests for this, because it would be a lot easier for us to debug what is happening if we have some tests. But one thing that happens in Go is that if you don't start with tests, since we did here, we might have to rewrite some of the portion of the code to make sure that it supports tests. That would not be fun, but like we have to do it, because like it will make debugging the error that I'm having now like super easy if we had a way to do, if we had tests, because then the test cases will be failing. So there's a new client. This is this one here. And then sending message. I wonder, is it something to do how we're adding it? Like, I wonder if this endpoint is being called twice. Chrome does some weird stuff where sometimes it might request the same page a couple times. So I'm just wondering if it's just doing it here where it's just being called twice. Because we're getting 2 messages here that is being sent, when in reality, like, we shouldn't be getting that at all. Cool. So we have that one client connected, and then yeah, I think it's being called twice. Why is it being called twice? Okay, so I don't think we have an error here. I think just something weird is happening with Chrome, where Chrome is like making 2 requests. So let's just try, and let's just close everything. So we're not doing anything ourselves. And then, oops. Yeah, so this is being called twice. So not sure why it's being called twice, but like, I'm just gonna ignore it for now, because this is not how it's gonna be working. We're gonna be using the Twitch API. Like, the reason why we're doing this, like how we have it now, is because it was the easiest way to test it. But I'm gonna get rid of this. So this endpoint, this request is getting called twice. And that's why we're seeing the double messages. So every time we call that, it's gonna just return 2. It might be because, maybe it's because I'm not returning anything. So maybe let's try returning something here. This one, I don't want to write, but So restart it. Yeah, it's still been called twice. So I don't know why it's being called twice. So for now, I'm just gonna ignore it. Okay, so our server send event side now supports closing this. So we could it supports adding when a client connects, we capture that client and we create a channel for it. Then when a message gets sent to the message channel, we then take that message and we send it to all the clients that are connected. And then from there, if a client disconnects, we handle that too. So let's say that the person leaves that page, we don't want to keep that connection open. We're just gonna close it. So that's kind of what we're doing here. We are just closing the connection as we go. Cool. So the connection is being closed. We're not keeping connections that are not being used. So I'm gonna just remove a couple of print statements that we might not need. So the starting one, cool. And then I'm gonna do a bit more cleanup. So since we could move this here. So we're gonna make this a bit more reusable. Or we could just keep it in. Should we keep it in there? But we do need a function, but maybe I should create a new channel just to do like stop. So like stop, and then we could make this case listen for a stop. Well, let's see. No, let's just do that. Yeah, let's do this. So we could do h.string shutdown. So we're shutting that down. We're tuning off the stream, and then I think this just needs to be a boolean and just be like if it's running. Yeah, so let's do that. So here we are gonna set this to oh, I also noticed that we never changed back the age. We should probably change that back next. Okay, so it's running, and then here if it's not running, we just don't do anything. Yeah, so if it's running, we want to close all the channels. If not, we just do nothing. This will protect us from trying to close channels that were already closed. And then we are setting h that is running to false. So that means, so the way that we're doing it now is that we took some of the code from here and we set it in a method for the string, and then that means we could call this method as much as we need it for the future. And this is what we're going to be using for our testing. So cool, and then it's running, shut down. Cool, I think we might be ready to start splitting this thing up and try to figure out how to write some tests. The only thing that will be a bit difficult for writing tests for this, for the stream, is for the event stream, is that it just keeps the connection open. So we will have to figure out how to do that, how to stop the connections. Okay, so I think let's just make a new directory. I'm just gonna call it server, and then inside of that server, I'm gonna create a new file called string, or let's do events. Naming becomes a bit weird for Go because that's kind of how the pass is gonna go for. So I think I'm gonna go stream because we could do stream that events, and then that could be our the way that we handled the class. So let's open the server, and then let's open a new file. Let's do server, and then main.go, and then let's just split it and do server string events. Okay, so now this, and this is gonna be called string. Cool. So here we could just take all of this methods and structures and just move it over to here. So we're gonna put it here. So now we just relocated everything to a new file, and so we could just create like a module for handling events. And then we could just rename this to, oh, we could just want to keep a string. We could rename this to event. And then since we're renaming, we're gonna have to change the age to our event. So event. Then we just have to go to every single place and change this up because we changed that one variable. So we just want to make sure that everything's working as it is, and then we just have to go back to our main file and just rename, import the new stream package that we just created. So we did this a bit backwards. Usually you want to write the test first, and then, well, you want to write the test and the code together. We ended up writing its server first, and now we're going to try to write the test for it. So we might have to go back and make some big changes to be able to handle tests. So we do stream event. That would record it for us. Cool. Also, because the way that Go works is that lowercase variables names are private. That means we cannot really access any of the variables that we're using. So we will have to figure out like how we'll handle that as we go to. So this is now. So because we gave the package that just call it stream, we could just do stream.new, and then we just call the different functions from it. And then we have, I'm gonna rename the run into start. So let's just do that now too. And start. Cool. So that's that. And then to send messages, we just need to just make this capital letter. Same thing with clients connecting and client disconnecting. We're just gonna make those public available by just making the first character uppercase. So we need to do message capital M, the client C, and this one here. Now the downside is that we have to go everywhere else that we made those public. Every time that we did that, we just have to go back and just like change them. You could get around this where, you know, if you make your tests before, like when you're writing your code, you could give your test a different name. Package name, and then since you give it a different package name, it won't be able to access the private methods and the private variables. So that's kind of one of the benefits of also doing tests. It's just you're able to get around some of these things, like knowing which methods and which variables you need to make public. Okay. So it seems like that. Get it? So now we have a new package that has all our test information there. Sorry, all our it has everything for the stream in one place. So the next thing that we could do is just create a we could look into creating a test. Okay, so let's just try writing some tests for this. So okay, so the first thing is we need to create a new file and just call this events test go. And then yeah, so here you could just give it something named like stream test or something like that, and that means that when you do that, you are only able to use all the public values of that package that you're testing, which is very helpful. Like it's very helpful to do that because then you're testing your package how other people are going to be using it. So it's super helpful to do that, and like that's kind of one of the benefits of it. So we could go here, and then here in stream tests. So for now, I'm just gonna keep a test. So we could start like writing our first test. So for test, it will be something like test stream or test event. And then here, the way it works in Go is that it just checks for the type of the function. So when you do the test command, it will just check for the type, and then so it will always check for this class here. Sorry, for this signature of the functions. So if the function has the signature, it will just run it as a test. So we could just try that out. We could kill this for now, and then server stream. Then we could do go test. So we're just setting it to run any test there. It's gonna be like, oh, okay, it passed because you have one test case that does nothing. It's just gonna say okay. So we can make it fail. So we can do t that fatal. So then if we run the test again, it just fails. So that's kind of the cool thing. It's like it's very simple to write the test itself. And we could look into, so in our case we're using a package that I made called HTTP server, but Go comes with a HTTP server for testing, so we could use that. It's called HTTP test, I think. Yeah. So HTTP test makes it super simple to write, to like just spin up a server in Go for testing purposes only. And then you only have to pass the handle function for it, which makes it super easy to just go and you can just write your own test right away. So that's kind of the cool thing. It's super fast to do too. So you can just write a super fast test, and then you write it. Then when you're done, you're able to go back. You don't have to like worry about like setting up like the different things that you would need to do for your test. So it's super straightforward to do too. So we could try using that, and it should be like super straightforward. Give me a second. Cool. So we could just start that. Just try doing that. So we're gonna go back here. So we're gonna use HTTP test. So HTTP test. Also the cool part about HTTP test is that it picks a random port for you. So if you have like 50 or 60 tests that are all spinning random servers, HTTP servers, and you're worried that it's gonna have like a collision or something like that, the HTTP server will handle, like the HTTP test server handles that for you automatically. So you don't have to worry about it, like all the different issues that you will have when you're running tests. It's like you have like port collisions, you can have pretty much anything but ACP test handles all that for you. So you just have to create a handler. So for now, I'm just going to create a func handler. Yeah, let's just create a func handler. So that func handler is just gonna just take another function. So we get the func. Cool. And then in here, we just need to make sure that we have the writers. So I'm just gonna take these writers right here. So the writer is pretty much the same function that we had in that we have back here. So if we go here, let's go back. Start from scratch. So yep. So the function that we need to reproduce is this function here. This is kind of what we need to remake. I wonder if this should be part of the string package. I think it should be. Like, that will make it a lot easier. So if we make that part of the stream, the only thing that we need to do is like, yeah, I think we should make it part of it. So if you make it part of the stream, we don't have to create this handler here. And the only thing we are doing is just like, so if we move it, we don't need to create this here. And we just have to pass, we could pass the stream into itself, into the handler. So, oops. So when we do this here, right, we could just, instead of having to do, create a new structure here, I could just do string and just pass the stream to it. So let's do that, because that will make it a lot easier. And then since we do that, we could just copy this whole, like we could just move this whole thing, and we could test it as part of the work. And we don't have to, we could just, it's gonna be cool. Because we don't have to worry about recreating the this function like for the test themselves. So it would just be like one thing that you'll have to do. So this is called event. So here, I just have to take this off. Just put E. And same thing here. Cool. So now that this is part of this handler, yeah, now that it's part of it, we could just let's just save this again and get rid of it. Let's just make sure that it's saved. And I think I'm shadowing, because stream's name is string here. I'm messing up the import on the tab. I just want to make sure I just rename it to something else, so there is no collision. Or I can just call it event, since we are calling it event internally. So event. Let's see what that error. This is missing, but it's there. So there is something to do with my editor. So let's just exit. Yeah, that works. Something weird was happening with my editor. So for recapping what I did, so we had a handler in the main package that was just handling the streaming of the events over to, so it was handling the clients connecting. Oops, sorry. It was handling the clients connecting, but it was also trying to, so it's handling all the different states that a client could be in, and it was handling also sending the messages for the client. And I decided to move it to inside of the stream package, because it made more sense to make it there. Because when I started writing the test, I just started writing the same thing here, so it just felt like I was duplicating code. I moved it, and now since I moved it, I don't have to write all of this here. I could just do, I think I could just pretty much just do event here, and then I could do event new, and then let's just go back here and see what we can do. So okay, so we have to close it. So when the server starts, so let's call it server. When the server starts, you then defer it and you close it. And the reason why you're closing it is that if you don't close it and you have like 5 or 6 tests running at the same time, all those tests are gonna just even if you're not using the server is gonna continue running. And at some point you might end up out of file descriptors. To summarize what I'm doing so far, so the current goal for me is like I want to be able to show the followers when a new follower subscribes or starts following me on Twitch. I want to be able to show it in the stream, but I also want to show it. I want to be able to get a notification so I could welcome them to the stream. I want to be able to just see that someone subscribed so I don't miss them, and I could welcome them to the channel as well. That's kind of the goal of the stream. What I'm building right now is called a server send event server, which just means it's a fancy way for a HTTP server to send events to a client. So when the client connects for the first time, it's going to create a connection. It's going to keep the connection open indefinitely, and then it's just going to send messages to that from there. So yeah, so and now I'm just trying to write some unit tests for this, because the way I did it, I wrote the code first and then didn't write any tests. So now I'm just like writing some tests. And some of the benefits of writing the test was pretty much like making the handler, moving the handler. Like I wouldn't have moved the handler unless I wrote some tests for it. And since I wrote some tests for it, it just makes it a lot easier for me to be able to move things around. And then we could just start figuring out like where certain things belong as we go. But that's pretty much where we are. So now we're just using something called HTTP test, which is something that comes in the Go standard library. So one thing that I'm not sure if you have noticed, but this whole thing is using just standard libraries. So I haven't used, with the exception of this package here, which is just also using standard libraries. It's something that I ended up building myself. So pretty much we're just using as much of the standard library as we can to build this. Because usually if the standard library handles most of the cases, and you might not need to use any third-party dependencies. Like the only time you will need a third-party dependency would be like if you want to do something more fancy. But what we're doing right now is not too fancy, so we could continue just using. We could just continue. We could continue using the standard libraries. Cool. So the next thing we could do is just use HTTP GET, which is like reading the body. But the only issue that I need to figure out is like, since we're not closing the connection, I'm not sure how this is going to behave. So I'm just going to take this here and see what happens when we use it. So I want to change this to the test to fail. And then, so what the sample here is doing is just doing a GET request to an URL. And then it does the GET request, then it goes through, it checks if there's an error. If there's an error, it's just fail completely, and it then reads all the whole, like everything from the response from the body, and then it uses IO util, which just reads the whole content of the response body from the HTTP request that we did on the top. So I'm just going to do the same. And then it just closes it, because again, since you're doing most of the cases where we go, it's like you have to close the resources that you're using. So let's say that you read the body, but you never close it. Then you have the memory is not released because it's just waiting for you to use it. So I think I'm just going to use all of this for now and rename some of this stuff. So because we are using the HTTP test package, and we're creating a service with the HTTP test, there is something called there's a variable called URL, which just gives you the URL where your test server is running. And since we're not giving any path to it, it's just gonna be running on the root of it's just gonna be any path. Like if you do /events or just /, it's just gonna work because we're not giving a route for it. And then just gonna keep that there for gridding, and let's see what grid is. So let's bring that. So I should change this to usually you just want to fail if there's an error in your test. We also need to send a message. So let's just send a message here before we do anything. So it connects, and then here we could just do event that message, and then we could just be like, we're just gonna send hey to it. So we're sending hey, and then here we can just rerun the test and see what happens. I think it's just gonna get stuck and never I could be wrong, but I don't think the HTTP client, if you use it, the default settings, it's just gonna continue and never time out. Oh wait, so fun fact is that we never started. Yeah, it just got stuck. Okay, let's just go back here. We never started the event, so event.star. So there is that. We never started it, but now it's stuck, so I need to go and kill it. Let's see. Okay, so I killed it. I had to go to the activity monitor and kill it there because it was just going and going. It was just waiting. Okay, so we can just start it here, and then we could just do the same thing. We start it and then we defer event that. So yeah, so the thing we're gonna do now is like we're using defer again. So we're starting the server. So we're creating a new value for the event, and then so we create a new value with event. Then we start the event stream server, and then we defer. So defer just says when this function, so when this whole thing finishes running, just run this here. So it's gonna run this function here. So it's gonna shut down the server. It's pretty much the same thing here. It's just shutting down the server as it goes. So that's kind of what we're trying to achieve here. So let's see if it gets stuck again. I think it will still get stuck. Yeah, it will still get stuck. So we just need to figure out how to handle. Yeah, and since we're closing it, it's just like, let's see if we're getting the event though. So we put an event. Oh. No, so here's the issue that's happening. It has to be async. So this line is blocking the test. So this is gonna block until the server replies back. And if it doesn't, since we're adding the event here, it wouldn't get there. So we could test that out. So we could do, we could print something here. And then see if that happens. Oops. But at least now we could just like, we don't have to go to activity monitor to shut it down if anything weird happens. Yeah, so it's never getting there. It's never getting there. Wait, let me make sure, because so in Go, any print statements you do in the test, it wouldn't show up. You have to pass that flag. You have to pass -b. So yeah, so we see now we're seeing the test server. Yeah, this is connecting. But now it's waiting. So it's connecting, but now it's waiting until the message comes through. But since we're not giving a message, so here's when we send the message, but it's never gonna get there because it's waiting. Line 20 just indefinitely waiting until it gets a message. So we just have to figure out a way to be able to handle that. Hey, how's it going? Hey, Eric. Yeah, so that's pretty much it. So I need to figure out how to handle that. And let's just recap again what I'm doing. So I am building a server send event server, which allowed us is going to let us send events to the browser from the client. From the server. So it's like if you have worked with WebSockets, it's kind of the same thing as a WebSocket, but the only difference is that a WebSocket is pretty much a different protocol. So it's not even built. It depends on HTTP, but it's kind of like its own version of it. So it does like some upgrading when the connection is done. When it's establishing the connection, it does like an upgrade, and you have to use a completely different stack to be able to handle like low balancing requests for it. In the case of a server send event, it's more of like it's just HTTP. It's an HTTP connection that the client is opening. So you could use a TLS, you could use you could have the traffic being corrected and things like that. The only difference is that it's just built on top of HTTP, the protocol itself. So it doesn't close the connection. When the client opens the connection, the server is never going to close the connection to it. And since it's never going to close the connection, most of the time when you go to like google.com, it will send you the payload of google.com and then close the connection when the request is done. In some cases, you could keep it open for like a couple of seconds in case there's another request for google.com, and then we just send it to you again. But in this case, it's just keeping the connection open, and just constantly, so it's gonna flush. So every time it gets an event, it's gonna flush that into as a payload. What is happening here is like line 20. So I'm writing some unit tests for the server send event that we wrote yesterday, and we made some fixes today. So I'm writing some unit tests right now. The thing that is happening now is that line 20 is blocking. So what that means is that it's waiting for a response from the server. But because we are always keeping the connection open, it will never get a response back. So the thing we have to do now is just be able to, so we need to go, let's see what I want to do here. Okay, I think I will need to make a new channel. So I will need to make a channel. So the issue is that I will have to make a channel, and then when I get a response, I then move unblock that channel. So it will be pretty much just block. So I would call it something like request done. So we just want to make sure that the request is done. And then that channel is just going to be so that channel is going to be used for, so I'm going to move these things. Let's just get rid of this for now. So I'm going to get rid of this for now. And then I will need to move this into its own function. Into a Go routine. So it will look something like Go func. So I'm creating a new thread. So I'm creating a new Go routine, and I'm feeding this here. And since I'm feeding that there, I have to go here now, and then I'm gonna block. So I'm gonna block until the request is done. So this will help us with the async call. And then for here, we have to pass, since it might not be able to access it. No, it should be able to. Let's just try it. Cool. So we have done, and we just have to call done down here. So we're just gonna do request done, and then we're gonna just pass through to it. We can also pass false since we're not listening to it. Okay, so since line 23 is blocking until it gets a response from the server, we're just sending it to a different thread. So we're using a Go routine to send this to make it async. So we could do two things at the same time. So we're gonna be making the requests at the same time, and then we're also gonna be sending a message to the server from the server to the client, so the client could have some information. So we could try that, see if that works. So event that. message. So we're just doing hey here, and then we just want to make sure that this finishes. So we're gonna do print done, and then here we just want to make sure that at least we get to this part here. Cool. So let's close that. And now let's see. Oh, I missed. Oh, I copy it. So sorry about that. So cool. So we kill it. Then we send it. Maybe I should just raise that. Something's on T. So let's see. So let's make sure that this one gets called. So making request. So I pretty much should only use print statements for debugging. So if you see me making a bunch of print statements, it's because of that. Something is up with my adder completion. So let's just exit out. Oh, it's not saving it. So let's just one and one. Yes. Okay. So something was happening here. Oh, for some reason it didn't save. Okay. Cool. So that's kind of the main issues. The fatal wouldn't work, so we just have to do that error. And then we have another fatal, so doing that to fix that, those linting errors. And the reason why it wasn't finished in the first place is that this was missing, so or why I didn't want to save. So and message, and then we send hello, hey, and oh, so there's that. And here we want to make sure that we do. So I want to make sure that here we do we print something. So let's just save it first. Let me see if that, yeah, it's happy. So let's print something here that says that is parsing the response. And then let's say that the message was sent. And that we're done. So a recap of what we're doing is, since we need to do things a bit using so it's gonna be parallel that we're gonna be doing things. So to keep track of the if we don't block for a while, that means that we have two things happening at the same time, and one might finish before the other one. So what I'm doing is like I'm creating a channel. So a channel blocks until it gets a message through it. So I'm blocking a channel. And then here on line 40, I'm blocking onto the channel, gets a message. And then the message itself is going to happen here in line 36. So in line 36, what I'm saying is we have completed all of this logic. We have run all of this here. And since we have completed all of that, the request is done. So let's see what happens here. That's interesting. So this is okay. I think it's blocking here again, but yeah. So it sent the message. You know what? It's sending the message. So maybe I need to send a message here. So that no. So I think the request is starting event stream. So this is gonna be a bit difficult because we need to start listening. Right here, when the go routine starts running, we need to be able to send the message. So let's figure out how we would do this. So the issue right now that is happening is like, would it hold? No, it wouldn't hold the message because there's no clients, right? So since there's no clients yet, it's just gonna do some weird stuff because there's no clients. So we need to figure out a way to make it. Oops, this is wrong though. Yeah, we have to make it wait for a bit before we send the message. And then when we send the message, we need to make sure that we could go back to it. And then, yeah, so let's see how we could do this. So we need to wait until the client is listening. Maybe I could just block. This is gonna be, let's see if this works, but I don't like it already. So we're gonna use another channel, and then we're gonna just do done. I'm probably gonna name it better, but for now, just because we want to be able to handle some, like, we want to make sure that the client is connected. So we want to make sure that the client is connected before. Okay, so let's see. So send. Okay, so it's starting new streams, and yeah, so it's still weird because it's still sending the connection. So we just have to figure out a way to maybe let's see if there's a way for the HTTP GET. So this is gonna be a bit complicated just because we want to handle everything is asynchronous. So I might skip the test if this gets a bit complicated because it seems like it's gonna get a bit complicated. But let me see if there's a way for me to subscribe to a. I don't know if there's gonna be an event or something that I could use to know when the request started. So that if you look at it, I am sending the event. Sending the event before the client connects. So like I said before, is if you don't write your tests at the same time you're writing your code, you're gonna have to make some changes. So maybe the thing I need to do is like add a channel, like not even. Let's see. So sometimes you're gonna have to write specific code to be able to test it. So one thing I could do here is like I could just do client connected, and then here it just I'm not sure if I want to send back the client. For now, I just want to know if it happens. So I'm just gonna deploy just like say like a client connected. So a client connected, and I'm gonna send it every time a client connects. So so the reason I need this is because the connection, like if I wanted to write tests for this, the connection is happening before the message gets there. So if you look here, the client is connected, but I send the message right before. So that means that the client would never see the message, which is one of the side effects that happens when you're doing a lot of async, like asynchronous programming. You end up with like this weird case where you're like, okay, so is this happening or did this just happen? So the goal here is that I'm gonna, so I don't need here, I don't need this anymore because I'm gonna be using it. So I'm gonna be using the event one. So what I did now is that I have an event now that tells me when a client connected. So I'm saying when any client connects, just send an event to this channel. And I need to make so I have to close these channels as well. So I need to close it, and I have to initialize it as well. So I think that this will help us a bit. So if the client connect, so when a client connects for the first time, we're just saying like a client connected, and so and from there we are going to send a message to that client that just connected. And then cool. Okay, so here we're now waiting for a client to connect, and then a client will connect here. Then this channel will get a message saying true that a client connected to it, and then we're gonna send the message. So see what happens here. Okay, cool. So we're parsing the body. So we did get the message. So we send the message. So the client connected. Then we send the message, and then we're parsing the body. So we're here now. So now I think we're this might be the issue. So let's see. So let's just, yeah. So I think we might be waiting for it to complete. So I might have to, this might be blocking. So now we have another place that's blocking. So line 28 is blocking because the way it works is that it's waiting for the HTTP request to finish sending all the data. Even if you're saying get read all, it's just gonna wait until it has read all the bytes of the request body. But because we're not sending all of it, we're just saying like here's some pieces of the body, and I will send you more later on. It's just gonna keep waiting. So if I move that here, so yeah, so it did just wait. So if you look here, when I closed it manually, it just waited for it and just printed the last byte, like the bytes that we send them. But it just stopped there. It didn't stop there. It just kept waiting. So we just need to find a way for us to read a chunk of the message and then move on to the next thing. So I will have to figure that out because I haven't done this in a while. So the thing that we're going to do now is we're going to have to go and read the body. So the request body, we don't have to read it. Sorry, let's just make some changes here. Yep, it's way better. Cool. So the changes that the thing that we have to do now. So utils is not going to help. This is not going to help at all because we have to read bit by bit. So I have to, the way I will probably handle this is that I will have to read the body using one of the readers, and then just go bit by bit. So I haven't done this in a while, so I have to look into handling like request body. But the best thing is that I'm just gonna look at the Go code base again to get some more context of how they would do it. So they're reading all here, reading all. Most of them are using reading all. They're reading all the body. I don't want to read all the body. I just want to read a piece. Like, so this one is reading all of it too. I just want to read a piece of it and then move on. So I think I could just start building something. Let's see. No, this is. Let's just. What is this one doing? It's getting a body. Okay. This is what we need. Cool. So what this does here is that it's gonna look. You're gonna create a byte array, and then you're gonna tell it how big. So here, this is a test that they're doing already for us. So we just do what it says it's doing. So we just have to tell it like, this is how big the response that we're getting is gonna be, and then we're just gonna have to read that the set of bytes of the body, and that will help our problem. And then like here, you have to handle like if you run out of space or something like that. but the way that the result is going to be in buff. So buff has the result that we want. So we're just going to turn into a string later on. But that should get us into a good place. Cool. So we don't want this anymore. So we're going to do, what do we want? So we're sending, what we'll be sending is, so want. This is what we want from the response. Cool. Okay, so what we want is we want to get event thing, and then we're gonna get a new line, right? And then we're gonna get data, and inside of data there will be a space, and then we're gonna get hi, hey, and then here we're gonna get 2 new lines. So cool. So that's what we're gonna get. And from there, maybe I could just declare in here. Cool. Then we're gonna just stream, and then cool. And then we're gonna create a new variable called buff. And then here we're just gonna create a by array, and we're just gonna give it the length of want. So what we're doing here is that we're gonna be telling the body. So the body itself is a Go interface, a reader. So when we do response that body is a reader, and then I could just do that read, and then I could just pass a buff to it, a by array. So you're telling it that you want to read these many bytes. So the way that you tell it how many bytes you want to read is you tell it the length. So it's going to use the length of the array, and then based on that the length of the array, it's just going to take all those bytes and just going to it's going to go one by one and read them off, and then it's going to append them to the buff as it reads them. And then here, one of the cool things that it does, it returns the number of lines, or the number of bytes that it read. It also returns an error. So if we went here and we saw that it returns the length. So you could check like if the length doesn't match. So you always want the length of want and to be the same, because you're expecting the same length from what the server sent to what you want. And then the other thing that you're expecting is like if you read too much, so let's say you only have 1 character and you read 2 characters from the buff, from the reader, it's gonna throw an end of line error, and that means that there's nothing else for you to read. So that's kind of where what will happen here. I'm just gonna take this here as well. So here we just want to do that error and just be like, what did they do here? Yeah, just do the error. So we could do, so it's erroring out because of the things. The length doesn't match, so we could do red length, and this is a integer, and then an error. So what we're saying here is that we're expecting this is what we read, but this is what we want. So we just gonna have to do this too for the error. So we want the error is 3, and then the next one is want. So we want a length D, and we want to also just check the error. just in case. So, and we close that, and then we do and error, and oh wait, there's no error here. We just want the length. And then so with error, and then what we want, so do length again here. Cool. Okay, so and let's just move this one. Okay, so this means that we now are reading, and we don't need it. So this means that we're reading from the body. So whatever they get, the ACP.get returns, we're reading into a buffer, and then the buffer itself is the length of want. So whatever want is going to return. And then based on that, if it doesn't match the length or we get an end of file error, we then just return an error. And then here we're going to print it and then close the request. So let's see what we get. So I might have, what did, no, it's the same. What did I miss? Oh, I might miss, no, let's see. We also want to trigger this. The test failed, so just make sure that worked. I'm glad I failed there, because if not, got stuck again. Yeah. Okay. Cool. So it's now closing the channel, which we needed to do. Okay. So what it's doing now is that it's filling here. So let's just make some changes here. Oh. Let's just, for now, let's just do this, where we just don't check for the end line. I don't think we might need that one for this test. Let's just try that. Okay, cool. So we're getting the message, then we are printing the message here. I moved it done, which we need. So now we're reading the body. So we made some improvements here. So now we're reading the body of the of whatever the event sent server is sending. So we could take that now and just take it and move it from there to so the only thing was missing is this here, where we were telling that it was done. So it's done. Let's see. So we might have some errors because we're closing some channels that are closed. So let's see. So we're doing star, and then we're going client disconnected. So the client is disconnecting because the request ended, and then we're trying to close a closed channel. So let's see. Client disconnected. Client disconnected. So message is sent. So we're line 23, 38. So he's panicking because we're trying to close a channel that it is closed already. So let's see. So this is closed, but oh, that is weird. So we're getting a nil channel. So for some reason when we're here, something else connecting to it. Let's see. So client disconnected, client disconnected. So that means that now Let's see what this is here. So what is happening now is that we're trying to do some operation on a nil pointer. So we just have to fix that. Yeah, so I think if it's nil, we just not do anything. So if yeah, if it's nil, we should skip it. So let's just do that. Client equals nil. Equal nil. Oh, we don't need those parentheses. So if the client is not equal nil, we're just gonna remove it from everything. So that fixes one, but where is the other one? 34. 34. Client connects. Wait, why is it client connect being fire? So 34. That message should be sent already, so I'm not sure why is it trying to send a message being closed. Channels could get very messy. I try to avoid them as much as I can, but the only issue is that we need to use them here because you want to be able to communicate between different goal routines. So we just have to figure out why is this channel, like why are we trying to write to a, like why is something is trying to connect to the channel when it's just empty. So we just need to make sure that yeah, so like why is there a empty client connecting to it? So oh, it's trying to read more. It's trying to read more, and then we just need to figure, because we're closing it here. It's trying to read more, and then a new one is it's a new client is starting, and then because we're closing everything, we're turning down the server. It's just like freaking out because we're closing off the server. So let's see where for now let's just not shut it down, and then we could go, wait, we're not shutting we are shutting it down, so we're shutting it down here. So we're shutting it down there. Yeah, so it works directly because we're not shutting it down. But why is there a client? So the client disconnects. We know, so we can just do if string buff not equal want, and we return an error. We fail the test. So this is pretty much what the test will be doing. So the test itself is just it's comparing what it's getting from the server to what it's being sent. So it has the server sending some data to it, and then it has the data that it wants, and so it's comparing both of them. And if they don't match, it's gonna throw an error. So this is what I got, and this is what I want. So, and then we pass. And then we do want. Cool. So just run this again. So it still passed, right? Because we are it should match. It shouldn't be cache. I'm not sure why it ran cache. Okay, that's better. So if our test doesn't change, if Go detects that file didn't change, it just caches the test. So it will never rerun a test that it knows that it was successful. So yeah. Then there is that. So now let's see what I could do here. So I don't need this anymore because it matches. The only thing that we have to figure out for our test and to be done is just like we need to go back and figure out what is happening with the done. Maybe I shouldn't use defer. Maybe I should just shut it down myself manually down here and see if. Okay, so let's do band that shut down. And see if you have the same error. We most likely gonna have the same error. Yeah. There's a new client trying to connect. Why is there a new? Oh, I know why. It's because these channels are gonna fire. Since I'm closing them, they're gonna fire. At least I think this one's gonna fire and just be like. So maybe I should just like. If it's okay, do something. I think that's pretty much what I have to do here too. Let's just do that here. If the channel is open, do something. If it's not open, just ignore it. And the reason why this is happening is because you're getting the close event as well. So you're getting the value of when a value gets sent to a channel, but you also get it tells you when the channel gets closed too. So that's what is happening here. It's like the select statements are being triggered because of that. So pretty much any place that I'm using, I'm just waiting for the channel. I need to check that the channel is open. If it's open, I'm gonna send the message to it. If it's not, I shouldn't do anything. So this is kind of in the last stream I was like, hey, I don't need to use OK here, but I need to use OK because the channels themselves are closing. And then since they're closing, I'm getting an empty message back. Yeah, there we go. So that pretty much our test is successful now. So we wrote a test. So now we could try to see if we could break it. Let's say that instead of, so we have hello here. So instead of hello, let's just change it to something else. So let's do like hello. So hey, sorry, hey. It says hey, not hello. So let's change this to hello world. So two things are gonna happen. Well, one thing is gonna happen. It's gonna fail like line 34 because the length doesn't match anymore. Yeah, so it doesn't match anymore, so it's gonna fail the test. So it's failing. And then it's failing line. Oh. Yeah, so it's failing really bad. It's failing in a weird way because it's counting everything and then just cutting off halfway because again, since we're using length here, it's just doing some weird stuff. So let's just change this back and just like put a 2, put a 3 here or 2. See what happens. Okay. So it pretty much panicked even bigger because we're trying to read something out of bound. What this means is like we try to read too much out of the buffer. So there is that. Cool. So this works. One cool thing that the Go tool does too. Save. Cool. One cool thing that the Go tool does is that you can see the test coverage too. So if you do cover, you could see how covered this test is. So the test that I wrote checks 84%. Sorry, it touches 80%, 84% of the code that the event stream. Sorry, server send event stream handles. So that's pretty much it. I think I am gonna call it a day for the stream. Thank you so much for watching. It will be, if you want more of this content, please follow me. I will be streaming daily for the next couple of weeks or every other day, depending on what I'm doing. But yeah, I will see you later. Thank you so much for your time. Give me a second. Since the server is not running, you guys are seeing a black screen, but I have something there. Let's go back to the terminal, then back to and yeah, thank you so much for watching, and please come back. Have a nice rest of your day.